In this video, I'm going to show you how to solve motion problems in your word problem packet. Motion problems are on page 77 in your packet. So I'm going to work the sample problem with you, and then I'm going to work one that has airplane. So we're going to start with the water one. In Grape Creek, Jim can row 30 kilometers downstream in 3 hours, or he can row 18 kilometers upstream. What you have to understand is that if you've ever been in the water on a canoe, whatever, that the water is adding and the current is adding to the push, which means that you go faster downstream, and when you're coming back upstream, you're going against the current. So the first thing that you have to understand that the letter S, like in snake, is still water, and C stands for the current. If you are in still water, you are being pushed with the current. That means you're adding. When you are going upstream, you are going against, which is minus the current. In these problems, it's still distance equals rate times time, but you are having your rate is a two-variable equation. So we are going to take the rate and we are going to multiply the time and we are going to get the distance. So in this case, downstream, he can do 30 kilometers in 3 hours. 3 hours, 30 kilometers. But upstream, he can do only 18 kilometers in the same amount of time. So you have two variable equations. The way the book would like you to solve them is they would like you to use the distributive property, and that is one way to go. So the example that's on the top of your worksheet does it that way. But you know I have a quick trick. If this number and this number are divisible, as in 3 goes into 30, I can just divide 3 into 3 and make it 1, and divide 3 into 30 and make it 10. I can do the same thing here. I can divide 3 into 3 and make it 1. I can divide 3 into 18 and make it 6. You will notice that that totally cancels out the front of this equation. And now I have a simple two-variable equation where I have naked C's, so to speak. I can add straight down. I get 2S is equal to 16. I divide both sides by 2. That is an S for still water. That is not a 5, although you may think by looking at it it's a 5. I get S equals 8. It is then very easy to put this back into the equation and say 8 plus what equals 10 must be 2. And I'm just going to double check it because I'm a nerd. 8 minus 2 does equal 6. So your still water, the current at which the river is running, is 2, and the amount that they are rowing is 8. Now let's go to an airplane problem. Let's go to Joe flying. This is number 5. Joe flying his small airplane. We said the exact same thing holds. If you don't like S and C because your S's or my S's look too much like 5s, you can certainly make them X's and Y's. And then it fits what we did in that exact chapter. He flew his small airplane 900 kilometers in 5 hours with the wind. So he flew 900 kilometers in 5 hours. He flew 700 kilometers in 7 hours. You will notice again that they have very politely or very nicely given you something that's divisible. So if you'd like to quote unquote reduce or simplify, you could just divide that. Divide this by 5, you get 180. divide this by 7, divide this by 7. It's like reducing a fraction. You divided this by 7, you divided this by 7, you divided this by 5, you divided this by 5. So you get better numbers. Once again, add straight down. You're always getting 2s because the c's cancel out. You're getting 280. S equals 140. Remember, this is an airplane. You are not rowing down a river at 140 kilometers per hour. That can't happen. Then I plug it back in. 140 plus what equals 180? Well, most of us can figure out that's 40. Nerd time, check it. 140 minus 40 is 100. So those are my two answers. You have 2, 3, 4, 6, 7, 8, and the rest of the word problem packet to be working on during this class period. I would suggest you use the time that you have to the fullest extent and not be playing around and get some of these problems done.